Hi, welcome back to geometry. It's been a while. This is chapter 6. Chapter 6 is all about polygons. Polygons, we are going to explore them in a variety of different ways. We're going to mostly focus on quadrilaterals, quad meaning four, laterals, sides, lines. But in this section, we're going to investigate all types of polygons. So, keeping in mind the activity we did today in class where we investigated polygons, interior angles, we're going to take some notes on that now and then practice what we've learned tomorrow in class. So a polygon is a closed figure formed by three or more line segments. This isn't in your note template, but just take a look. You probably are familiar with this already. So the word polygon derives from the Greek word meaning poly is many, and gonu is knee. So a polygon is a thing with many knees. It's got all these bends, polygons. It's got these bends in there. Otherwise, in our world, known as vertices, right? Polygons can be concave or convex. Concave means that they have like a cave in. If you were to draw a straight line on their side, it would go inside. Convex means if I had all of these segments as extended lines, none of them would cut through the inside. So convex is all sticky outy, concave, it's got a cave in, it's got a pushed in part. Regular is when all of the sides are congruent and all of the angles are congruent. Now, polygons are made of segments, three or more line segments. So a circle, not a polygon. And it has to be a closed figure. So this figure here, not a polygon, because it's got an opening. Can't have any openings to be a polygon. In a few minutes, you'll fill in the table on your notes. So this was just an introduction, so we can talk about some things. So let's begin the note template. Geometry 6.1, the Polygon Angle Sum Theorems. Angles, you're familiar with now. Polygons, we just discussed. And sum, that means when you add them together. Our objectives for today's lesson are to find the sums of the measure of the interior angles, interior, the inside, and to find the sum of the measures of the exterior angles. Those ones are on the outside, exterior. It's essential that you understand the sum of the interior angles of a polygon depends on the number of sides the polygon has. So that's the variable. It depends on the number of sides. By dividing a polygon with n, the number of sides, into the number of sides minus two triangles, you can show that the sum of the interior angles measure of any polygon is a multiple of 180. So we're going to explore that today, and you discover that in today's class through the activity. So the first theorem you want to take notes on your template is the Polygon Angle Sum theorem. The sum of the measures of the interior angles of an n-gon. N-gon is the term we use to describe any number of sides in a polygon. Is this, the number of sides minus 2 times 180. So all of these shapes down here all represent polygons. N is the number of sides. So for this first one, just watch. You don't need to write this down if you don't want to. The number of sides, 3 minus 2 times 180. You already know this, that every triangle has exactly 180 degrees in it. You could do this for any of these, and we're going to explore this through a few examples. So the n in this formula, the n is the variable that represents the number of sides in the polygon. So to find the sum of the measures of the interior angles of an n-gon, any polygon, is the number of its sides minus 2 times 180. So finding a polygon angle sum. What is the sum of the interior angles of an octagon? Octagon, octo, like octopus, has 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. We're going to use the formula, the number of sides minus 2 times 180, to find the sum of the interior angles of an octagon. number of sides minus 2 times 180. So in an octagon, it's 8 minus 2 times 180. Simplified, that's 6 times 180. There are 1,080 degrees in an octagon. So take a minute to fill in the vocabulary in your note template. An equilateral polygon. The definition of an equilateral polygon is a polygon with all sides that are congruent. Equilateral. Lateral meaning sides. And draw the picture. Remember, these little hashtags means these are all congruent to each other. An equiangular polygon. Equiangular. Equal angles. It's a polygon with all angles that are congruent. And again, recall that these little arcs represent that all of these angles are congruent. A regular polygon is a polygon that is both equilateral and equiangular. So it's both equilateral and equiangular. All the sides are congruent, all the angles are congruent. The next two words that we have are convex and concave. I did talk about them a little bit at the beginning. A convex polygon has no angles pointing in. Or more precisely, no internal angle can be more than 180. So, no cave-ins. In concave, it has an internal angle that's greater than 180. Or it's got a cave-in, a pushed-in spot. Or if you think of it this way, if you draw a line on any of the sides and the line goes inside of the polygon, then that's concave. If you draw a line on all of these sides, none of them will cut into the interior of this polygon. So this one's convex. All the sides are sticky-outy, concave. It's got a cave-in. Even if it's like a tiny little cave-in, it's still concave. So take notes here. The corollary to the Polygon Angle Sum theorem. Corollary means something we can easily prove. The measure of each interior angle of a regular means all the angles are congruent, n-gon, so any number of side polygon, is the number of sides minus 2 times 180. So that would give you, this top part will give you every angle on the inside, so all the measures, divided by the number of sides. So to find one angle, that's what we're looking for here, each one. So you're looking to find one, you would say the number of sides minus 2 times 180 divided by the number of sides. So in this situation, we have a pentagon. It's 5 sides. So 5 minus 2 times 180 is going to give us the interior angles of this pentagon. So in this situation, we're going to have how many degrees? Yeah, 540 degrees inside of a pentagon. Well, this is a regular pentagon. So we can divide the sum by the number of angles, which is the same as the number of sides, to find out how much each one is. So 540 divided by 5 will tell us how much each of these interior angles is. 108. When you say 540 divided by 5, we're going to get that each one of these angles is 108 degrees. So that's the corollary to the Polygon Angle Sum theorem. The essential part of this theorem is that it's a regular polygon, so that you know all of them are congruent. All 5 of these angles are the same. That's why we could divide 540 by 5 to get each one of these angles. So using the corollary to the Polygon Angle Sum theorem, what's the measure of each interior angle of a regular decagon? Because it's regular, we know all of these angles are congruent. A decagon, deca like a decade, means 10. So we'd use our formula. The number of sides minus 2 times 180 will give us the total sum of all the angles inside this decagon. And then we need to divide by the number of sides in order to find how many degrees each angle is. So, if we substitute in these values, 10 minus 2 times 180 divided by 10. 10 minus 2 is 8, and 8 times 180 is going to give us 1,440 degrees. And then we want to divide by the number of sides. So we're going to determine that each one of the angles in this regular decagon is going to be 144 degrees. We can also work backwards using these formulas. Given that the sum of the interior angles measures of a polygon with n sides is 1080, let's find n. So, again, using this formula, the number of sides minus 2 times 180 will give us the total measure of the interior angles of a polygon. So if the total measures 1080, how would we work backwards? We want to isolate this variable, so we want to get this n all alone. We need to get rid of everything that's over there with it. So our first solution step would be to divide by 180. We want that to go away. What you do to one side, you have to do it to the other. So now, we're going to be left with the number of sides minus 2 is equal to 1080 divided by 180 is going to give us 6. And now we want to undo or isolate this variable, so we have to get rid of minus 2. We would add 2 to both sides. So the number of sides on a polygon that has the interior angles that have a sum of 1080 is 8, which we already did this example a little while back. An octagon contains 1080 degrees. Another way we can use the Polygon Angle Sum theorem is to find one missing angle if you know all the rest. What is the measure of angle y in this pentagon? Well, the first thing we need to do is to determine how many degrees are in a pentagon. So, using that formula, the number of sides minus 2 times 180, determine how many degrees are in this pentagon. 1, 2, 3, 4, 5 sides. We know there's 540 degrees in every pentagon. Now, we need to subtract the angles that we know to find this one that we don't. So 540 minus 110 minus 90, don't forget about that one, minus 120 minus 150 is going to give us the measure of angle y. When you simplify, the measure of angle y is equal to 70 degrees. So first we found the sum of the measures of the interior angles of this pentagon. Then we subtracted the angle measures that we knew in order to find the one we didn't know. And don't be fooled by this 90. The last theorem we're going to talk about today is Theorem 6.2, the Polygon Exterior Angle Sum theorem. The sum of the measures of the exterior angles of a polygon, one at each vertex, is 360 degrees. So exterior angles are the ones that are on the outside. So this is a pentagon. I have 1, 2, 3, 4, 5 exterior angles. You can only draw the extended lines in one direction. One way for you to think about this, and I'm going to show you a graphic tomorrow in class that'll help you visualize this better, is it's 360 degrees. You know a circle is 360 degrees. Exterior angle, to find one of them in a regular polygon, is 360 divided by the number of sides. So let's use this. What's the measure of an exterior angle of a regular pentagon? Now, we know pentagons have 540 degrees inside, but on the outside, pentagons in every polygon has 360 degrees. So, in order for us to find the measure of one of these, we need to say 360 divided by 5. So the measure of one of these angles is 72 degrees. All of these angles equal 72 degrees. We had discovered earlier that each of the interior angles of a regular pentagon was 108 degrees. These are a linear pair. They form a straight line. 108 plus 72 is 180. That's going to be true of every pair. We'll explore this more tomorrow. Please make sure you come to class with any questions you might have.